Coming to you from Long Island Sound, where the hippest music can be found, like a buried treasure underground. Clam Radio, on the ocean floor and having fun, spinning tunes since 1961, getting absolutely nothing done. Clam Radio, airwaves, sound waves, from under the real waves. Clam Radio, Clam Radio, Clam Radio.
Can you dig it?
Radiation cripples a nation, a nation, a nation. Fuel rods broken, leaking, smoking, melting
Have a nice day.
Fukushima, the other F word. Hi, this is John Tobacco, and my guest is computer scientist Bob Ball. And today we will be discussing the ongoing nuclear meltdown at Japan's Fukushima Daiichi nuclear facility. We're going to talk about what the dangers are and what we can do about this nightmare. How you doing, Bob?
I'm doing great, John. I'm thankful to be here.
Yes, that's right. You haven't been here for a while.
I haven't been here for a year.
Yeah, it's been a long time.
It's been a while.
We've been talking about this disaster here at Fukushima, and you've done a lot of research since the last time we talked about it. Obviously, a lot of years have gone by as well. And so I wanted to know, like, how long you've been studying this? What have you been doing?
Well, as far as my knowledge of this area, I could either confirm or deny where I learned it from, but that should be enough. But the point is that, I have a radiation detector, as you know. I've been getting concerned because we did a show on this, I think it was back in 2014.
Yeah.
We were getting about 2.5 to 3 times normal background radiation. As a matter of fact, students from your university, they were picking up over 500 counts per minute on a pile.
That's a lot?
Yeah, it's a lot.
Okay.
It's basically getting like a CAT scan.
Really?
Yeah. And you were concerned about it. I was explaining how it was going to melt, and it was the total snow pile of all the snow that was put down in Stony Brook for about 2 months, and they made it into this pile and melted down into the sewer, which,
into the water
you'll
system.
see it in the groundwater in approximately 40 or 50 years.
Wow.
And I was saying, how the water you're getting now from the artesian tables from the time when there was a tremendous amount of aviation and potato fields on the island,
Right.
so you're getting toluene and pesticides.
Well, were you making the connection with Fukushima back then, or were you saying maybe it's Brookhaven, or
Well, we on
Indian Point,
my son worked for Brookhaven, and my cousin did too. And I know that, for example, that Brookhaven has been leaking tritium for approximately, 45 years.
Wow.
Tritium there's no way to really contain tritium. Okay, the only way you can contain tritium is with gold. So they're not going to build out the precivishal, that they have in the reactor out of gold. It's not going to happen.
Where does the tritium come from, though? Is it something
It's water. It's heavy water.
Ah.
It's an isotope of water. There's what's known as called the Wegener effect. Basically, it takes metal and it makes it into Swiss cheese over time. The neutron bombardment of the metal knocks the atoms out that are in the lattice of the actual metal, and it causes essentially premature metal fatigue.
Really?
This was all studied on in the atomic testing in the 50s. There's a lot of work written about this, and that's what also the alert about what's going on in the Pacific has to do with a lot of the work that they did back in the 50s and the fallout they had from those nuclear tests.
Yeah,
and
sure.
people saying, "Oh, well, it's not the same as all those, nuclear tests." And
What
they
it's
don't.
worse? People think it's worse, the nuclear tests? Or
That they think the nuclear tests are worse, but they're actually less.
really? Wow.
Yes. But for example, in one nuclear pile that they have at Fukushima, one pool, there's over 14,000 Hiroshima bombs worth of fallout. 14,000,
Yeah,
right.
so
And in one pool, the pool 3, they had MOX fuel. So they had what's known as called plutonium-239, which I think the human tolerance, some people say it's 1/1,000,000th of a gram. I'm gonna be conservative. And I'm going to say the tolerance is, say, 100,000th of a gram. But
Such a
there's
small
170 tons of it.
that'll kill everybody.
So it doesn't really matter,
Yeah.
okay? And that's what these people don't seem to understand. Like, you have these naturists and these shills that say, oh, well, it's not that bad. The Pacific Ocean's a big place and whatnot. Well, what they don't understand is a few things. Like, some of them only look at cesium, okay? But there's over 2,000 other isotopes that are related to fission products. Some of them are half-lives are very short, like iodine, like xenon is only 9 hours, okay? 135 is only 9 hours. Xenon 131 is approximately 9 to 30 days, which if you do the calculations of the half-life, it could be...
So you're saying at that amount of time, it gets the strength of it is getting cut in half? Is that what you're saying?
Right. It's what's called a beta decay.
Ah.
Okay. Let's talk about the fission process. Okay.
Yeah.
So you have an atom of uranium. Okay. And it splits. All right? And the uranium we're talking about, there's two different split of elements, essentially. You have your heavier element that splits to, and then your lighter element that splits to. Okay. And then you have some products in between. Now, the problem is that when the uranium is all together, okay, the package of the atom is what's known as fissionable, which means if you hit it with a neutron, it could either absorb the neutron and it could be converted into like plutonium, for example,
Right.
or it can split with the neutron. And when it does split, it usually releases more, 2.5 times more neutrons, to further the chain reaction, okay? We explain this as, how many ping pong balls are in mousetraps in a room. And, for example, if there's no ping pong balls and mousetraps are set in the room and I throw a ping pong ball, it'll set off a couple traps, but it won't go crazy, okay?
Right.
That happens to be what's we call criticality, okay? So there's subcritical, critical, and supercritical. At any rate, so if I put ping pong balls, though, on every single mousetrap,
Right, one goes
which
off,
is
they're all
just
gonna
like
go-
the enrichment of a nuclear device, okay? Say, for example, a thermonuclear bomb, okay? And I throw just one ping pong ball. Boom.
Yeah,
Okay,
they
the
all
whole
go
thing
off, right.
cascades, and that's what you have. What's known as called a yield. Okay, that's how much matter E equals mc squared. Matter is converted into energy. And what they were doing with these atomic tests, the scientists, is that they were going ahead and sending these devices off, knowing that the cores were about the size of a baseball, okay? And that they were converting, those cores into a nuclear device. Believe it or not, a core about the size of this, my hands I'm holding about a softball, they got it down to about 20 megatons.
Wow.
Packed with tritium and it's
insane.
It's Quindy. It's insane. Yes,
It's insane.
It's totally insane. But that's not that much material. Okay.
Right.
And yet there's a tremendous amount of fallout given from that material. They've had incidents with Japanese freighters and other kinds of fishing fleets and whatnot because, things went awry. The explosion got out of hand.
Right.
But still nothing in comparison to the amount of radioactive material that's in Fukushima. For example, there was a critical explosion. Now,
there's a picture of it.
There was hydrogen explosion. They all thought there were hydrogen explosions, but no, one of them was actually critical. And they know this because you can see in the illustration, pool 3 literally goes up about 1,000 feet.
Yeah.
Okay, and they found parts of the core literally 2 kilometers away. Okay. Literally, okay? So that's bad, okay? And that's where Plumegate is. And if you read the NRC reports, which I've been diligent in going through, millions of pages, they knew
nuclear regulation
regulatory. Yes.
Oh, okay.
You can go to the website. It's on the government website, and you can see for yourself. Patrick Henry, he goes by Patrick Henry. He did a whole bunch of research on this. He's done a bunch of YouTubes on this. We don't know where he is anymore. He disappeared.
They shot him up.
Well, we don't know. Okay,
that's suspicious.
Rad Chick is another girl on YouTube that does quite a bit of reporting. She doesn't have the scientific background. She does more of a green the planet kind of thing, and she can sometimes fall susceptible to the green quote agenda. Okay, right. So we know that there is a $2 trillion industry at stake here. We have we have 23 of those Mark 1 plants still operating here in the U.S., and there's another 100 Mark 4 plants, which are different, but it's the same essential design. There's differences in it. Basically, all water reactors, or BWRs, are terrible. Okay,
what does that mean, BWR?
They boil water reactors. Okay, their whole scheme is terrible. Water only has really 100 degrees to play with, which isn't really that much. That's centigrade. Okay,
right.
It's not that much to play with, and if you really want to have an efficient reactor, something that's going to do things for you as far as not only just produce power, but the biggest energy cycles are, with industry, such as fertilizer, steel, all kinds of manufacturing things. We need something with very high amounts of power, which is a nuclear reactor, but it's a molten salt nuclear reactor, which the nuclear fuel is actually melted in a lithium bromide salt, okay? And there was what's called lifters. Kirk Sorensen does a great piece on this. And anyway, those are reactors.
That's more of a newer technology. The other stuff you're talking about that we have is 30, 40, 50 years
1947.
1947, so we got to do an upgrade, man. What's going on?
If you want to look at what's 1947, you're not really using anything that's from 1947. I mean, you have certain guts that are the same as a 1947 thing, but they've been modified. So we really don't have anything like that. Molten salt reactors were actually invented by the guy who invented the pressure water reactor. But the thing is that a thorium-based reactor or a pressure, they can't use the material to make bombs. So the Department of Energy didn't want it because they wanted to make bombs.
Right.
And they didn't want it because they really, all their sciences were doing with plutonium.
Right.
Okay, it wasn't really dealing with the chemistry of thorium and protactinium and all the stuff that's involved with thorium. But thorium is actually the way to go because it's approximately 98.7% efficient.
Ah, there you go.
Okay, so and it'll run on anything, okay? there's thorium in your backyard. I mean, you can literally dig up rock and have thorium. There's more thorium in coal waste piles, for example. So and with coal, you could make all the synthetic fuel that we need. Okay, really clean synthetic fuel if you process it through a lifter because of the heat you have on the other side. You're talking about operating temperatures which are 495 degrees Celsius to approximately 900 degrees Celsius. I'll put it in Fahrenheit terms. In other words, 900 degrees Fahrenheit to 1500 degrees Fahrenheit. You can use a much more effective, efficient turbine, almost 45% efficient turbine. So you're getting into very high levels of efficiency, which means that the cost of electricity would be only like a few cents, or in other words, $6 a month.
Well, that wouldn't make sense to some people.
It would make sense to a lot of people because it would free up a tremendous amount of human potential.
Yeah.
Okay, but you know, governments are 80% of their income can be traced to taxes on energy.
Energy, yeah, of course.
So that would really drastically reduce.
So that's
their
one of the
income.
things that we're up against. With a disaster like this, it's not getting solved as fast as it should, probably because there's the people in power. They don't want to shift over to something new and fix this and get the mindset to like we have to have a better way of making energy. Is that what you're saying?
Well, there's two things. Number one, they're like, oh my God, how can we fix it? We can't fix it. Okay.
Well, that's not true.
Let's talk about the nuclear reactor as it is. Okay. The model was essentially the Gillette, shaver model, which means, and you're like, what the heck is he doing? Okay. Gillette would go out and give away razors for nothing.
Right.
And you're like, wow, I got this great razor. And they'd put one pack of refills in it. There was like 3 or 4 refills.
Right.
And then all of a sudden you ran out of blades and you had to go get blades.
Yeah.
Well, you couldn't get any other blades. Like in the old days, a Gillette blade or another blade manufacturer, there was many blade manufacturers. It was just, the double-side razor blade that went in the shaver, and it was all the same, and it was standardized, and they were all competing on that basis. But what Gillette did by coming up with this new Track 2 razor and stuff is that they basically came up with a model, well, you have to have that blade, that razor, to essentially do stuff with.
Yeah.
So you're stuck buying that razor. So they gave away the razor for almost nothing.
Right, it was a smart move, actually.
But you end up paying through the nose. Well, they did the same thing with the reactors. They essentially built them at cost, okay? But because they are designed to only accept the fuel from that manufacturer, that's where all the money is.
Yeah.
The money is in the fuel, because the fuel has to be done every 18 months. They have to refuel. It's only 0.5% efficient. It's very inefficient. But because the nuclear reaction is 1,000,000 times that of a regular, chemical bond, that's where they make up the difference. But there are, again, better things to do. Like anything else, there's a better way to do it. Better way to do it. Okay, the Nixon shut down the molten salt reactor project in '73. And they've had nothing but successes. They've had tremendous successes in the project, and it doesn't work under pressure, doesn't need all this stuff. If it leaks, it goes into a drain tank, which is right underneath it. But if it didn't, say there was a hole in the side of it, it would just leak and instantly turn into crystal because, what happens to salt, it just turns into crystal. So,
well, I mean, the industry to build those things would be there, but you're saying the results would be cheaper ultimately, so that's where they don't want to deal with it. Is that what you're saying? I mean, why wouldn't they want to just, manufacture new stuff? You have, it's industry right there. You've got to build those things. But you're saying that because it's gonna be cheaper energy, more clean, efficient, they don't want to have that. Is that what you're saying?
Well,
like, why wouldn't they do that?
This goes along with what we said, okay? If you look at the industry in the United States from, say, 1957, okay, to 1969 when we went on the moon, tremendous changes. Because Kennedy had a vision, and they thought he was crazy. When he made that Rice University speech, they thought he was absolutely nuts. Okay? But he had vision. He said, well, we'll have to invent new polymers. We'll have to invent new
all the
alloys.
Great stuff that came from that.
New things, okay?
Yeah.
And what he did was he made, say you're a guy, a manufacturer, and you have all these vacuum tubes. He made them absolutely worthless, okay? He made a lot of things worthless.
Good
Okay.
reason to kill him, I guess. I don't know.
Well, they killed him for other reasons. The money was the big reason. He started printing our own money, but we're getting off the subject. But the big thing is that he had a vision. He put a laser beam, essentially on this is the goal, and then he went out to private industry and he said, "Okay, bid on it."
Right.
Okay, and I was involved in that, and many people took tremendous pride and effort doing that project right here on Long Island.
Yeah, sure. Your father was part of it.
And my father helped co-create multi-layer boards. I actually programmed the first CAD/CAM machine to actually drill those boards, so you can blame any CAD/CAM or robot on me. Actually,
robots. That's
but we had
story.
off switches. I confess, we did have off switches.
Good. That's
throughout the plant, we had big red switches. That's one of the things I look at these Boston Dynamic videos, and
Where's the off switch? This is a robot.
It freaks me the heck out because I'm like,
smarter.
where is the off switch?
Yeah, really. I mean, what
I
what are these
don't
guys
want
thinking?
you do whatever you want. I just want to see the off switch.
I know, man. It's scary.
So at any rate, the media is not mentioning this.
Of course not.
If we look at and this is why we know it's a problem. The one thing that's consistent about this is that the media doesn't talk about it on both sides of the fence. Let's think about this. We went through a full election, a very contested election, there was debates, and you would think, here's a reporter, here's a person, from the whatever, and they would say, what do you guys think about Fukushima?
Right. No, I never heard anybody say that.
Exactly, because
Never mentioned it at all.
nobody does it. So here's the Japanese prime minister, and Trump is having a press conference, and here's the Japanese prime minister, and there it is. Here's the reporters.
Nothing.
Okay, I mean, the first thing out of my mouth would be,
Right.
what's going on with Fukushima?
Yeah.
Okay?
Right. It's like the major thing.
I mean, I'm hearing all kinds of things.
Right.
What's the story? What's happening? But
They wouldn't talk about
nothing.
it.
A blackout. A total 100% blackout. And they made it illegal in their country. I know this for a fact because I have Japanese friends. They made it illegal in the country to report any ill health effects, any effects whatsoever. They can't report them. And any news can't report it. So you can't get any data.
It's a blackout. Yeah.
You can't get anything out of them. And they've lied every single step of the way. They've lied. And, and now, back in November, there was an earthquake. That's right. If you remember that Dr. Kaku was talking about this, that it was really not in a stable, cold, shutdown condition, that they were really hanging on their fingernails as far as the way the whole system was.
Right.
And he was going by, at the time, the information they were putting out.
Right.
He didn't know about all the other stuff. But he knew about the 3 core meltdowns. He didn't know that they actually melted out of the containment vessels, out of the plants, out of the whole buildings that are into the groundwater.
That's unbelievable.
Okay? But he did talk about problems if there was an earthquake. So in January this year, I posted on my Facebook because my alarm went off on my Geiger counter. And I forgot to bring it today. But as you know, I flipped out. Because in order for that, when that alarm goes off, it's basically telling you get the heck out or put on radiation gear.
Wow.
Okay, that's how serious it is. Because you're talking about the alarm is set for 0.1 microsievert. Okay, now let's talk about, everybody talks about counts per minute, rads, grays.
Yeah, how is it measured, radiation?
Spectrals.
Yeah, what is that all about?
Okay. There's different types of radiation. So let's discuss the different types. You have alpha. Okay, what the heck is alpha? What's alpha? Okay, alpha is 2 protons and 2 neutrons. You have beta. Beta is basically an electron, but it's like really energized. Okay, it's like pew. Okay, so beta is bad too. Okay, and then you have neutrons. Well, that's pretty simple. That's just the neutron. Okay, and then you have gamma. Okay. X-rays and gamma, kind of close. Gamma's higher. Okay, then there's cosmic. So you have cosmic, gamma, X-rays. I have this kind of myth argument with people all the time because the people like with microwave ovens and, oh my God, it's nuking my food and I'm gonna die and all. And, no. Okay, no. Microwave actually is an extremely safe appliance. Okay, and it's actually one of the things that still uses a tube, a vacuum tube. Now, the vacuum tube is not made out of glass; it's made out of metal, but it's still vacuum. and it actually uses a piece of thorium and a piece of tungsten.
Right.
And there's a high transformer in there that changes to high voltage, which tubes need, and it excites it, and it pumps electrons with two donut-shaped magnets on either side that essentially, through different cuts in the valve structure of the copper, makes like a fan effect that causes microwaves. Then there's a waveguide, and the microwaves radiate out into a waveguide, and the microwaves are approximately 2.45 gigahertz. Okay, that means they're oscillating at 2.45 million times per second. Okay, and there's a fan in the microwave oven that rotates and deflects the microwaves, and so they go all over the place. And then there's a table that turns and whatnot. Okay, but there's a door. It's shielded, and there's metal sides and it's shielded. Now there are things that can go wrong, and that can leak a certain amount of ionization energy.
I always wondered about that because you can smell food from the microwave, so there's got to be something going.
You can smell that. Well, how? Let me explain how a microwave works. So what it does is, water is a dipole molecule, which means one side is more partially positive than the other side is partially negative. And when these electromagnetic fields hit the water molecule tries to align itself with the magnetic field. So it's essentially vibrating at 2.5 billion times a second. And that friction of vibrating like that causes other molecules that are next to it to heat up. That heating is really no different, okay, to a pot you put on the stove. You heat up the pot, but it heats the food, all the food from the outside. Not just the water, but everything that's in there from the outside in. Okay, so it still breaks down proteins, breaks down things, and breaks down essentially life. Okay, because you don't want bacteria in your food. Okay, you want the bacteria to be dead or cooked or killed. So the microwave, for example, in different altitudes, it can be hazardous to cook food or meats in that, or chicken in that, for example, because it only gets as hot as the water gets. And so that's important, okay? So microwave cooking depends on the water content and the type of those are the cheap ovens. The more expensive ovens, like I have at home, and Advantium has actual heating elements in it too, and the actual halogen light, and it gets really hot. I mean, the oven actually gets 900 degrees, so it can do a baked potato in like 10 minutes, okay? I mean, really, with the, real baked potato, you'd have to put it in an oven for like an hour and a half to get the same result, because it's both microwave and conventional heating at the same time. So that's a misnomer. But once you shut that microwave off or open the door, the magnetron goes off, and there is no radiation. The radiation doesn't hang around. It's gone.
Right.
And it's not making the food radioactive, okay? Because it's really no different than light is. It's the same form of energy that we seeing light from that lamp.
Right. It's
just at a different frequency. Okay, so radio is at a different frequency, and AC wiring is at 60 hertz. Yeah, so it's all really the same. Okay, it's just the higher frequency you go, the more energy that wave has. Okay, so the more damage exposed to. Matter of fact, the guy who invented microwave ovens, a guy from Raytheon, he came up with the idea because the Hershey bar in his pocket, he was working on the radar set, was melting. It melted in his pocket. Of course, I didn't think to him, gee, this is bad to be exposed to all this radiation.
He's doing something
but he decided to build a radar range oven, an industrial one, Well, this would be really good to cook things with. I mean, the fact that he was getting cooked, it didn't hit the brain matter,
I guess not, yeah.
But with Fukushima, you have not only one, you have 3 cores. We know that we don't know exactly where the cores are, but we know that they're not in the plant. So we know that they're underneath the plant. We know that they're in the groundwater table. We know that there's steam coming out. There's extreme, and it's only going to get worse as far as the radiation goes. So there are biologists that say, oh, it's no. You sent me a link to an article. The guy was like, oh, well, there were atomic tests and whatnot. Well, Okay, so let's play devil's advocate on that. Number one, the atomic tests were bad, but they were bad for only that moment in time. And like I said, the fallout was minimized because they wanted yield rather than fallout. Okay, so there wasn't that much. Okay, it was bad. I'm not saying it wasn't. As a matter of fact, one of the reasons and tests that they do to know if a wine is a forgery, like some of these, wines are really expensive.
Right, but
They do a cesium-137 test on them because if it was bottled like when Ben Franklin was around, there wouldn't be any cesium-137 in the bottle. So it's one of the tests that they run on the bottle to detect whether it's a fraudulent bottle or not. That's one thing. Now, that did affect sea life, and there was cesium, but the Pacific, what they found is that the plankton eat the stuff.
Uh-huh.
And it concentrated in the plankton over 1,000 times their body weight. And that's bad because who eats the plankton? Fish, whales, other things. So it gets itself into the food chain. Now, with Fukushima, what you have is what they've released is they know that there's 300 tons a day of radioactive water that's been going into the Pacific since the beginning. That's what they're telling us. I think it's a lot higher than that. Okay, you see, the nuclear industry will, they were reading Betrol, but they've started getting so high, then they start talking about sieverts. Now, most of the time when we talk about sieverts, like on your regular Geiger count,
what is that? Well, sievert is a measurement.
It's a measure of what a joule a kilogram does and how it's absorbed. So, say if I'm at a baseball batting cage, and you're just like against the fence. And there's a pitcher at machine, and he's pitching balls to me. I'm hitting these balls, okay? Now, some of these balls are hitting in certain areas and that they're hurting you. Some of these balls are not, okay? Some of them are missing. So there's a certain amount of balls that are coming out from me, but some of them, like one that hits you in the nuts, that's not good, okay? So that's what sieverts is. Sieverts is what your body's absorbing from the type of radiation that it's detecting. So, for example, a neutron would be higher than a beta, okay? Certain X-rays would be higher than, you get what I'm saying, okay? Alpha, for example, will actually bounce off dead skin, okay? Cesium-137 is a high alpha emitter. But the problem is, this is where the problem is, and this is what they're not saying. When you ingest this, okay, then all of a sudden it's inside you. Yeah. And then it gets absorbed into your body, and then it's bombarding your cells with that. Now, some people say, whatever. Okay, well, what it does is it weakens your immune system, opens you up to viruses, opens you up to all kinds of things, and opens you up to cancer. That's what cancer, they're actually thinking that cancer is caused by viruses, okay? Starfish is a perfect example. Some people say, like I read in an article by that gentleman, he said that
it was a virus.
It was because of virus and because of global warming, and the Pacific warmed up, and okay. Well, let's talk about global warming. Okay, this Earth, if you look at the geological record, it's been, and it could have been more, but they know at least 5 times the Earth was literally frozen to the equator. The last time, the CO2 levels were almost 15,000 times higher.
How would they measure that?
They do it with ice.
How much is in the ice?
Right. They can see what's dissolved in the ice. And they, as they analyze the ice layer, they get a... Okay. So, and also in the geology, you have to understand, like I was having this conversation with before, do you know what the most common element in the crust of the Earth is?
Iron?
No.
I don't know.
Crust. That's the top.
Yeah.
Not the mantle and all that. Top. Oxygen.
Okay.
46% of it is oxygen. Okay? Mm-hmm. And what people don't understand is that everything is oxidized.
Right.
The rock you see, it's oxidized. A calcium carbonate is oxidized. Okay? So all this stuff is what we call carbon sequestered, which means just seeing this, right, there must have been higher amounts of carbon free in the atmosphere in the past. Has to be.
Right.
Okay, no offense or buts. If you look at the Earth 4.5 billion years ago, and it was all big volcano, whatnot, it had to, to have more carbon in the atmosphere.
Right, of course.
And it had to be like Pangea must have been, all, and the plants must have just thrived like crazy. Okay, because a plant's photosynthesis now is only about 14 to 20% efficient, depending on the plant. Okay, but as carbon levels go up, which is really not that much. 400 parts per million is not that much. They become more efficient. So they actually take up the CO2 faster, grow faster. So you could say the Earth has a lung to it, okay? But the biggest lung, 50% of the Earth, is the Pacific Ocean.
Yeah.
And they say, okay, well, it's the ocean is a big place. We don't have to worry about it, okay. But they've already come out and said, and the NRC documents said, well, TEPCO doesn't know how to stop it. They won't talk about, how to stop it. And it's leaking, and they can't stop the leaking, and that's what to do, and that's what it is. And I'm saying, okay, so is what it is, because it's going to leak forever, they say now. So forever is a long time. Yeah. So we already know 6 years. Okay, so say what this. We'll play devil's advocate. Say, okay, it's fine. Will it be fine in 50? Remember, at least 300 tons a day going to the Pacific for 50 years now.
Right, but they say it gets diluted by the water. But eventually, if you keep
but
doing it.
But the biologics concentrated. If the Pacific was a dead ocean, if there was nothing in the Pacific, I would agree with them. I'd say, yeah, okay, you're right. Okay, yeah. But they're also releasing radiation to the atmosphere. They've read at least 1,000 sieverts, and it's open to the environment. Okay, they've sent 7 robots in 6 years, then they all died.
Now, what do you explain that? What do you mean they sent 7 robots to check out the?
Well, it's so hot.
The meltdown.
Okay, there's so much radiation. It's probably gamma. Okay. And gamma and neutron flux, okay, which is extremely bad, very unhealthy for electronics. There's 20 million electron volts deposited every single time you have one of these degradations. And, that's not very good.
So what did they send robots in to see what was broken? Or?
What was going on, yeah.
Yeah.
And they recently... You could literally see the Wigner effect because some of the steel was black. That's a telltale sign of the Wigner effect. They know that from the 50s. And then they found a 2-meter hole, and core was gone. And they were reading. They don't even know because it broke the tube on the meter. Okay, so
when you're saying the core is gone, what exactly are you saying? You're saying that there's a floor there with radioactive material. And
right, you have what's known as called a pressure vessel.
Right,
and the pressure vessel is inside a containment vessel.
So that's broken. Whatever it's gone, it just went right through.
The pressure vessel, the corium essentially becomes a big blob of corium. The nuclear pellets are contained with corium, and it becomes a big lava pool over 5,000 to 6,000 degrees. Okay, hot.
Yeah, I'd say so.
And it melts right through the core. Okay, this stuff goes through concrete. It has an exothermic reaction with concrete. It goes through everything, and that's one of the reasons why the design is just terrible. Now, Alan Weissman designed the nuclear reactors for the Navy for their project of nuclear submarines. I think it was the Nautilus was the first nuclear reactive sub. It was only a 20 megawatt plant. Okay, the whole reactor, which was big, they make them a lot small today, but what was about the size of this room. And we're in approximately a 12 by 12 room. And it was put in, that was it. It was never going to be serviced. That was the lifetime of the boat. And they were never going to refit it, and that was it. And, maintaining atmosphere pressures of 90 to 150 atmospheres small like that isn't the biggest deal as when you increase the size. Then you're talking about the exponential thickness of the walls,
right.
See, because you're not talking about something that's 1 meter in length. You're talking about something that is over 10 meters in length, and and you're still containing the same pressure, so everything becomes a problem. The pipe fittings become a problem. Everything's critical. Everything has to be X-rayed to make sure there's no cracks in the wells and stuff.
Well, a lot of this stuff was probably caused by earthquake than just the tsunami itself, probably, right? I mean, they built it in a place that's just silly. Why would you build it?
Oh, you're not going to believe this. The truth actually comes out. One guy, he was from the BBC, he's a reporter, and I forget his name, but he was doing a documentary for the BBC, and he was there 3 years after the Fukushima incident happened, and he was seeing this sign. It was written in Japanese, and he says, what does this sign? He says, and they said this sign was approximately 250 feet off the ocean, the level as far as altitude, and it says, build no lower, no lower than this point. Because the geologicals of the area showed that they have actually had a tsunami 900 years before. That was actually over 200 feet.
Yeah, so they knew that,
This is not something, because you have to move like 1 million gallons, an hour to cool these reactors.
Why would you pick a place like that, though, to build?
If they had to move it all the way up, they'd have to get all that water from the ocean that much further, and it wouldn't be cost effective. So there's the guy from we can either give these raises to the guys or not, and, the cost-benefit analysis, and, so instead they put a seawall up, but the seawall was too low. Kaku talks about, they made a deal with the devil.
Of course.
They gambled and they lost.
Right. So there's really nothing that they're doing right now, as far as we know, that's making a difference in terms of stopping the radiation from going into the Pacific. We'll talk about how you can possibly do that, but right now they're sending robots in that are melting. So clearly they're way behind the times now at this point.
There's a reason why the Americans got to the moon first. And I know the reason why.
And that was because?
Because of our diversity. Okay, because we had
a lot of different
a German Jew working with my father who was a mutt, his English-Irish, and another guy who was an Indian guy, and, a whole bunch of different people working on this, but they argued like crazy. These guys used to argue like crazy. And when my father died in 1978, who do you think was at his funeral? And they were all crying, like little boys.
Yeah.
Okay, those guys. Because they did something great and they knew it. That's where innovation comes from. Those arguments that they had. The light bulb goes off and say, I got it.
Right, exactly.
I got it.
That's important to have.
Out of the box thinking, okay? So you and I, we've done this ourselves when we've worked in the labs, okay? And it's so great because you're coming from a different background than I'm coming from. And that's what we have overlaps and things. We love music and we love things. So in developing the SA3 process, I'd be there doing things, but then you would say something to me about something you heard or whatever.
Right.
And all of a sudden I'd be like, and I'd get it. But I couldn't have gotten it without you saying.
Right. It's good to have all these.
And you see that's more heads to the table. Right. We're not thinking the same way.
So you're saying the Japanese really aren't doing that. They're staying. They're not really. They're not out of the box.
Now this is not.
Is it just pride? You think?
I think it's because. I think it's culture.
Culture. Yeah.
I think that there's a lot of face. They feel a lot of these guys lived in the Fukushima prefect that they worked in. And, there's a tremendous dishonor. There's a lot of cultural stuff into this, okay? And I think that's part of it. So after the first 2 robots, for example.
Right, which are very expensive.
Which you would think that they would learn and say, well, gee, don't build another one because it's just going to... They went through 7 robots in 6 years, and they all died from the radiation. And, it doesn't take a rocket scientist to figure out... We have to rethink this. So the first thing they should have done was they should have called NASA.
That's what I'm thinking. Why wouldn't they call NASA?
Okay, because NASA has to deal with radiation all the time. They do it with their satellites. Right. They've done it with their Mercury, Mars probes. Because when there's a CME that's launched from the sun, it's like...
Forget it.
Wow, okay? And they did it with the LEM. So with the LEM, believe it or not, DuPont invented this special mylar fabric.
Right.
And it had 30 atoms of gold on it and then aluminum. So you'll notice one side was gold. Basically, it was crumpled up. And there was 2 things that it provided. There was a big problem being in space. There's no air.
Right.
And there's sun. So when you're in the sun, it's 250 degrees Fahrenheit.
Totally on, yes.
And when you're out of the sun, literally, like you could be in the sun, one half of your body and the other half would be 250 degrees below. Right. So you had a 500-degree range, which is like, whoa, okay? So what they did was they crumpled this new material up, and they used it as an insulation. But because they were folding it, it also did something else. It did a certain amount of radiation shielding.
Right.
Now, a certain amount. The astronauts were still going to be exposed to a lot of radiation, don't get me wrong. But they weren't going to be exposed to as much, believe it or not, because of those layers of gold. But more than that, the big thing that they were worried about was the circuits.
They'd be fried.
And the computers. So what they did was on every single IC chip that was on the spacecraft, there was a little gold cap on them, memory, everything. And the wiring was layered in gold, no lead, because they found that in space, lead actually grows crystals and actually will short the connectors out. Okay, they found this with the first satellites.
Right.
So that's where silver solder was essentially created, and gold plating was essentially, done. We used to plate everything in gold. These systems, okay, they had to rely on these computers for their lives. Okay, which means when they lifted off the moon, okay, there was nobody can go down there and get them.
Right.
So the engine had to work, the guide system had to work, the stuff had to work.
Yeah, it has to work, or you're screwed.
Okay,
no one's going to get you.
We're not talking about if, okay, we're talking about if there's a failure, there's no backup plan. And NASA hates that. NASA always likes to have a backup plan with things. And so Grumman knew this. And the specifications for the LEM was, it cannot fail.
Right.
And Grumman, okay, is used to build, pilots, Navy pilots will tell you, okay, they don't call it the ironworks for nothing, okay? Grumman got a reputation, okay, by pilots and other aviators that their planes are ridiculously tough. As a matter of fact, most of the manufacturers here on Long Island, their planes are really tough. There's footage of an A-10 Warhog that was built in the Fairchild plant right over here in Long Island and Farmingdale, where the wing was shot off. Most of the wing was shot off. Most of the tail was shot off. One engine was shot up. I mean, you couldn't believe this thing was flying.
Yeah.
And it flew back and the guy landed it. And they were looking at it. It was like a living wreck. It's a testament to the engineering.
Sure.
To the people here on Long Island, the pride that they took, and the engineers and the calculations that they did. One of the things that I used to say to my sons, where they said, "Well, Dad, how smart you are." So I'm like, pfft. I said, "No, so I'm not that smart. It's like everybody else is getting stupid," and I met people back then who were just incredible. They would carry the little pocket slide rules, and you wouldn't believe the calculations they would do on the fly.
So they haven't approached NASA about any of this stuff then, I guess. I'm surprised that nobody said anything.
Putin actually approached them, but then they turned Putin down. So you have to wonder why. But reality-wise, okay, Fukushima, and I'm going to tell you the truth on this, is a real extinction-level event. We cannot survive without the Pacific. Now, the same water that's there, okay, for example, will be here in the Atlantic in 54 years. So in 154 years, there'll be so much contamination to the planet that biologics dictate you won't be able to procreate. The first thing that happens is you become sterile. And they know this from the atomic testing that they did in the 50s. There's been many reports written up on this. So I put it to you logically, if you know that this is leaking, and it's only going to get worse, it's not going to get better, logic dictates you have to stop the leak, and you've got to stop it now.
Right.
You can't just let it happen and let it go. You can't do wishful thinking and that's really bad news.
So what is this, sort of like the little Dutch boy, he put his finger in it, but then meanwhile there's other breaks in the thing, and it's just going to get worse and worse.
Exactly. It's just like the little Dutch boy. So the way to do this, and Kaku came up with hats off to him. He came up with it. But this is exactly it. He's got Japanese descent, but, he's been in America enough to where he's teaching these kids and, he sees and he does these shows and he comes up with out-of-the-box thinking. He said, look, you tried to build an ice wall, but it's not going to work because you don't have enough power to build it. You really have to set up an ice wall that's a kilometer away.
How would you build an ice wall? Would it be like liquid nitrogen or something? Like, how would you
Exactly. You have to bring BP to the site. You got to drill wells down to 800 meters, and you got to he had a plan for 2 carriers, all the stuff off the carriers, just compressors to make liquid nitrogen, and 2 nuclear sub besides for power generation. Okay,
you'd have to keep that going forever, though, wouldn't you?
You wouldn't have to keep it going forever, and I'll explain to you. I'll explain to you what has to happen. So what they have to do is they have to build a wall first on the land side to stop the groundwater from coming in, and then the ocean side. Now they still keep putting water on the pile, but they're cutting out the extraneous water. Okay, and what they're doing is then at a specific point in time, they're going to take huge caterpillar, robotically controlled, huge catapults, like the ones that they use in strip mines.
Right.
And the robotics won't work on radio, okay? But they will work on either a projected laser beam line onto a mirror, okay? Which means you can have a feedback system where the cat is actually sending a laser beam back to a transmitter that's transmitting all the signals via laser beam, and those laser beams are being like a periscope. They're being hit into a periscope and it's being reflected down into a shielded area, okay? And that shielded area is then taking that data and figuring out what the commands are and then putting it to the hydraulics. And then it's going to bulldoze those buildings away, exposing where the core actually is.
Right.
Okay? And then the dump trucks, same technology, huge dump trucks, loaded with all of Russia's boron-3 they got, okay? Dumping tons of this boron with glass, sand, essentially, in these areas, okay? They're cutting, essentially, the water off and backfilling it. These cores are then going to be heating up. And hopefully they'll heat up and they'll melt into the heart of the earth, which is fine. They'll eventually get to the center of the earth. Okay, eventually.
Yeah.
Where there's a ton of that stuff down there. Okay, well, more than a ton. It runs out. It runs the whole planet.
Right.
But that's what they have to do. Now, if that doesn't sound daunting, then they have to fill the whole area up with almost 300 million square meters of concrete using China's new concrete technology.
It's feasible. It could be done.
It's
these exist. They
it's
exist.
feasible. Okay, I'm not going to say it's not feasible. It's feasible, but it would take the world to do it.
Right.
What I mean by the world, it would take China.
All the superpowers.
It would take Russia, and it would take us.
Right.
Okay? Then we need to build 30,000 tankers with lifters crossing the ocean, gathering up the water and processing it.
Wow.
Okay? Lifters have a very controlled source to where they can transmutate radioactive stuff to clean up the oceans, to clean up the radioactive debris in the ocean. Because some of the hot particles are in the top layers of stuff. They wouldn't be able to do anything about the plankton that's already infected or the fish that's already infected. They would either just have to let them die, decay, that's it. But if they stop the leak and they start cleaning the stuff up, within 30 to 50 years, the ocean can be brought back. And I put it to you this way. Wouldn't it be a good thing to see Russia, us, China, working on this for the sake of humankind?
Of course. Now, in case you've just joined us, you are tuned to WUSB 90.1 FM Stony Brook. My guest is computer scientist and polymath whiz, Mr. Bob Ball, and we've been discussing the disaster at Fukushima in Japan that occurred in 2011 and is still going on as we speak, and we want to get people aware of it and talk about ways that we can correct this disaster before it's way too late. It may be way too late now. Who knows?
It would take $2 trillion of real world GDP. Not money they print out of thin air. We're talking about real stuff. And remember, all that stuff, like those Caterpillar, mining equipment, and stuff, that all have to be sacrificed. Right. Eventually, they'd have to park that and cap it with concrete because it would all be contaminated.
It'll be contaminated, of course. Yeah.
And you'd have to have 100,000 volunteers because I guarantee they'd be exposed to a lot of radiation.
So what do you think the chances of that actually happening are going to be? I mean, how bad does it have to get? You know,
what people have to understand is that
future or what?
That Fukushima is really the AIDS of the planet.
Yeah.
Essentially, what it's doing is it's making the fish more susceptible to viruses. It's making the fish more susceptible to cancers. It's making the sea life, and that sea life is getting into the food chain. And again, the media doesn't talk about it, and they says, well, if it wasn't that, then why did all those fisheries from Alaska to San Diego have to declare a federal emergency and ask for funds? Because they only got caught $2 million worth of fish instead of the normal $32 million in Alaska.
Now,
that
do
they
you
normally
think that
catch.
they're associating that with Fukushima, or they just think it's climate change and stuff, and there's nothing we can do? I mean,
they're always going to say climate change because there's a nuclear industry, and the Department of Energy says, "Don't say the N
they tell them
word.
to shut up.
Don't
We'll
say
give you
the
the
N
money,
word."
but
The
you shut
N
up.
word, like we had this discussion before. The N word's the other N word, right?
Right. Yeah. Right. Exactly. Right.
I mean, you don't want to say the F word.
Right.
Essentially, Fukushima's become the other F word.
Yeah.
Don't say. I mean, here he is, the Japan's prime minister. All these reporters there. The first thing out of my mind would be,
of course. Why wouldn't they
what
mention
the
it?
heck is going on with this Fukushima thing?
Exactly.
You got to know what it is. What's happening?
What's happening?
We don't know what's going on. What's going on? What's the truth? What's happening?
They would never say it.
Now we do know what's happening because for your request, now they released 5 years. They released all the NRC documents, and they're all there to be viewed. And anybody can view them. And I'm telling you right now, there's over 1,200,000 pages of this stuff.
Wow.
And then why? Why is it released that way? And it's released in a way that's extremely difficult to read. Yeah. It's very difficult to find anything. And it's terrible, okay? And they do this on purpose because people and reporters today are lazy. Okay, and also they're paid by lobbyists in the industry, so they're not going to say anything. Why would they say anything? Because these industries own everything, so they're not going to say anything.
Yeah, but it's killing the planet. It kills everything. It's not just you. It's everything. So what is it? Is it a depopulation scheme at this point? They said, "Oh, we'll take advantage of this problem."
There's a girl on YouTube, Lisa Haven. She thinks that it's a New World Order depopulation thing. Georgia Guidestones. I think there's a grain of truth to it because we've been living longer and longer and longer and becoming non-productive. Basically, you're saying a person who's above 65 years to 70 years is becoming non-productive. So all of a sudden, there's almost 30 years of non-productive. Well, with this exposure of radiation, we're all going to get cancer and die by the time we're 65 to 70, if not less. So, there you go. Also, it makes...
That's really twisted, man.
It's twisted, but, there are some people saying we're slaves already.
People would just want to know in general, what can we do in the simplest terms? How do we get a chance? How do we do it?
Got to talk about it. Got to call your representative. Got to call D.C. Got to write your representative. Got to call the station. Got to call the media. Got to write the media. Got to talk to other people. Got to write other people. Got to talk to them. Even if they say it's not that bad. Okay, fine. Well, then when will it be bad? 30 years? 50 years? 100 years? 200 years? You see? So the fact is, if it is going to be really bad and possible at 200 years, well, then logic dictates you got to fix it now. Now, I'm telling you, it's actually worse than that, okay?
What would you say to someone that says, well, I want to go to California now, I want to go to Hawaii? If they went, I mean, they're exposing themselves, obviously.
Personally, I wouldn't do it.
You wouldn't do it?
Wouldn't do it. I sent a radiation detector to my cousin.
Yeah.
He was one of these nice, he was okay. And he lives in, I think, Riverside. And it rained. I said, well, capture the water in a bucket and then pour it through a coffee filter. So he wasn't getting any, Bobby, I told you, blah, blah. I said the coffee filter was wet. You got to let it dry.
Right.
People don't understand that water absorbs radiation. He let it dry. And I heard the meter on the phone. and he was freaking out.
Yeah.
Okay? Freaking out. And his readings were 10 times higher than the readings I was getting here. He got 1.4 sieverts. That's like radiation worker stuff.
Wow.
Okay? And that's about 10 times higher. And another guy called me who was getting 0.7 microsieverts from Dallas, Texas. And you can go into BP Earthwatch, you can see there's readings all over the country. I think they post counts per minute most of the time. That's kind of deceiving because you don't know what kind of radiation is. But for the kind of meters it gets, it's at a close approximation. Something to be alerted of. If you're getting, 50 to 100 counts per minute, that's not good.
Can we get these little radiation detectors on our iPhones or apps, or do we have to get a specific kind of device, like a Geiger counter kind of thing?
There's an actual
Where do
app.
you go?
There's an actual app that you can get, which actually turns your camera, which is a CCD camera on your phone, into a Geiger counter.
Wow.
And you get to, and it works. It actually works pretty good. There's also a thing you can buy from Amazon, which is like $30, and it's the actual part of the Geiger counter, the tube part, and it plugs into the smartphone, Android or whatever. I think it's 6. I think 7 doesn't accept the plug-in, and it plugs in and has an app with it, and it turns into a Geiger counter. My personal thing is spend $100 and get yourself a Geiger counter. BP Earthwatch has a really good one for sale. On their site. It's not bad. It's $100. And it's pretty good. That's one I got for my friends. You can call up a dosimeter agency. Radiological Field uses a agency, and they get a badge, and they put the badge on, and they get a dosimeter, and it tells them what's going on. You can get that I'll tell you, if I was living out in California, I'd definitely get that. If I was living in Hawaii, I would really consider moving.
So are there any precautions, like they say take iodine or anything like that? Or is there anything that would...
Well, I would definitely take nascent iodine. Potassium iodine can be detrimental to your health if you're not exposed to iodine 131. You want to load up the thyroid with healthy iodine. Because the radioactive iodine will get in there, and it's not good. They have detected iodine all over the place in different levels, different places. Like I said, when you have some place that's so far away that's emitting so much radiation, it gets all mixed up. So there'll be different areas of the country that'll be hot and cold. There's no saying what will be hot and cold.
And so do you recommend when people take a look for their food, if you see something that's from that part of the country or whatever, not to have it? Or
I would not eat any fish from the Pacific at all. Any fish from the Pacific. I would be suspect of that. This is another problem. 60% of our vegetables come from California.
I know.
And they've been getting dosed with all this rain, and some of it's been hot. And that rain is going on that soil, and some of that soil is taking up cesium and strontium and all these kind of elements. And they're not talking about that on the media at all. And so now you gotta worry about what you're eating.
So look at your foods, look at where it's made.
Buy local.
Buy local, yeah.
Buy as local as you can get, because that's basically what you have to do. But yeah, we all the radioactive reactors that are in the United States that are water reactors have to be in a cold shutdown and have to be retrofit with lifters like immediately. Mm-hmm. Indian Point is an example of that. Now, you're going to say, well, let me tell you something. What did they discover in this last raid in ISIS? Guess what? Every single nuclear reactor location. Every single one.
Really?
Yeah.
That's not good.
Now, I don't know if you've seen specials on who's guarding these things, but they're usually retired guys who couldn't run 50 feet if they had to.
Okay, this is John Tobacco. This is Clam Radio. We've been talking to Bob Ball. I brought him here to talk about Fukushima. I guess it's a meltdown, right? Would you call it? Or
3 core meltdowns.
3 core meltdown. It's happening in Japan as we still speak after, 7 years? 6 years now. So it's something that we really have to concern ourselves with. Talk to your congressman about it, right? Get the word out. There's ways to take care of it.
Do the research for yourself, folks. Look up Plumegate. Go to the NRC files and see. And what you see you might not want to see, but you'll see it.
Well, again, it's been a long time now. So I don't know how bad it really
6
is.
years
that,
of leaking every day.
Yeah, that's just out of control. That's out of control.
Exactly. And so it has to be, and logically, we have to cap it. We can't wait any longer. We need to clean up the Pacific, no matter what.
Okay. Well, thanks a lot, Bob. And
Thank you, John.
yeah, we'll have Bob back, and we're going to probably
And
discuss.
thanks for all out of serving. Thank you.
Yeah, I appreciate that too.
And a hi out to my sons.
All right. We won't take your crap. We won't play your game. We won't wait and let it slide while you shrug off the blame. We won't take your crap. We won't play your game. We won't wait and let it slide while you shrug off the blame. What gives you the right to inflict your dumb beliefs on us without a fact in sight? Do you feel some kind of relief from us to think we'll cower down? Well, you got another thing coming to you next time you're in town. We're gonna kick your ass. We won't take your crap. We won't play your game. We won't wait and let it slide while you shrug off the blame. But we won't take your crap. We won't play your game. We won't wait and let it slide while you shrug off the blame. Most of us, we get along, we work together fair. Then you come in and wreck the joint without a bit of care. When the bubble bursts and the oil flows, you're first to run away. Well, screw you, distant traveler, it's time that you should pay. We won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off the blame. We won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off the blame. Some other factions may be fooled by your elegance and style, but underneath your velvet words a viper with a smile. Flawed by ego, arrogance, super pride and greed. You need a change of attitude, that's what we know you need. We won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off the blame. We don't need your speech, we don't need your voice. We don't need you telling us that we haven't got a choice. We won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off the blame. So many times you've lied, you don't know when you are lying. Man, you fooled yourself in thinking you're a god. But all your house of cards are burning, all your covers have been blown, stripped of all your thieves. Now the emperor has no clothes. We won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off the blame. We don't need your speech, we don't need your voice. We don't need you telling us that we haven't got a choice. We won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off the blame. But we won't take your crap, we won't play your game. We won't wait and let it slide while you shrug off